So this question says, given that the shortest distance from the point A to the x-axis is 5 units, find the possible values of alpha. Alpha here is just the z-coordinate of A, and A has x-coordinate 1, y-coordinate 2. Okay, so if we draw a diagram, right, we can easily draw the x-axis like that, right? We draw the x-axis, and then A is just some point around the x-axis, right? And in fact, if we draw it like that, actually we can draw the distance as 5, right? The shortest distance is always the perpendicular distance, okay? So in fact, the distance 5 is just the line, the distance from A to whatever this point on the x-axis is, right? And in fact, this is not the only point that is distance 5 from the x-axis, right? Because we could go another 5 units in this direction and end up with like some other point here. This could be another possible point that is distance 5 from the x-axis, and this gives us a hint as to actually how many values of alpha there are, because we can hypothesize that one value of alpha will give us this point, and then another value of alpha will give us this point, right? Possibly. So probably there are 2 values of alpha that we need to find, and we'll see whether this is true later on. But for now, let's ignore this extra bit. I'll erase it, and we focus only on this point A here, which is here. Okay, that is distance 5 from the x-axis. Okay, the x-axis, let's call it L, and then this line, which is perpendicular to L, let's call it L0. Okay, and then this point here, right, that's the intersection of L and L0, let's call it B. Okay, actually one of the things you can notice about B, right, is that B lies on the x-axis, right? So if B lies on the x-axis, then obviously its y and z coordinate must both be 0, right? Its x coordinate, well, we don't actually know yet. So let's just call it x, okay? Or x0 so that we don't confuse ourselves with the x-axis, okay? So the equation of line L is easy enough to find because it is just the x-axis, right? So in words, let's let L be the equation of the x-axis, and the equation of the x-axis is easy to find because it's just a lambda times 100, right? Where lambda is any real number. And then the equation of L0 is slightly harder to find, but let's just write it down here first. L0 is a line perpendicular to L, passing through A. Okay. Then we define B here, right? So let the point of intersection of L and L0 be B, which is x0, 0, 0. Okay. This is just writing what we figured out in words from the diagram. So one thing to notice is that, well, since L and L0, they are perpendicular, right? The direction vectors of the 2 lines must be perpendicular. Okay, and what does perpendicular mean is something that you should be very familiar with. Perpendicular just means the dot product is 0, right? So since L and L0 are perpendicular, right? The direction vector of L, which is 100, right? Is from here. 100 is from here, and the direction vector of L0, right, is actually, well, you can get a direction vector out by just taking AB, right? AB is a direction vector in the direction of L0. correct? So it's 100.ab should be 0, right? And but AB is not very hard to find. AB is just OB minus OA, right? So that's x naught minus 0, 0 minus 1. Oh, I did that wrongly, sorry. That's x naught minus 1, 0 minus 2, and 0 minus alpha, right? This should be 0. And in fact, you can actually just expand the dot product, right? And then you can tell that this is just 1 times x naught minus 1 plus 0 times this is 0, right? And then 0 times this is also 0. So actually you get just x naught minus 1 equals to 0, right? All of these disappear, right? And then you can solve for x naught. X naught is just 1. Oh, that's easy enough. And with that, we can actually move on to solving for alpha. Okay, because now that we know that x naught is 1, b actually is just 100, right? So b is 100. Okay, I write this here. This is the new thing that we found. And b is we already know it as the closest point to alpha, right? The closest point to alpha is going to have the shortest distance from alpha, which also means that this distance, right, AB, must be 5, right? You can see it from the diagram, and in fact the question says it already. So that means that actually the length of AB is 5, right? And the length of AB is, once again, not too hard to figure out, right? AB is just OB minus OA, but we know B now is 100, A is 1, 2 alpha, right? So this thing must equal to 5. Agree? And if we just do the arithmetic, right, this is going to be 0 minus 2 minus alpha, and that's 5, right? That's 5. And then if we use the Pythagoras theorem to find the length, this is just square root of 0 square plus minus 2 square plus minus alpha square equals to 5, right? And I ran out of space, so I'll just draw a line here. This is just square root of 4 plus alpha square, right? Which is equals to 5. Then we square both sides. 4 plus alpha square equals to 25. Alpha square equals to 21, meaning that alpha, if you solve for the quadratic equation, is plus minus 21. And that's it. 2 values of alpha, right? As we hypothesized in the beginning. One of them is plus 21, plus square root of 21, and the other one is negative square